Hey everyone, this is Eddie Does Math. Welcome to my channel. If you'd like access to all my annotations from today's video, you can click the link below, enter your email, and you'll have it in your inbox in less than 30 seconds. Now let's take a look at some common misconceptions you'll see in Algebra 2. The first common misconception that we see is distributing errors. So if you look at this very first one, notice how we have to distribute that -3 to all terms within the parentheses. So when we distribute this -3, we do get -6x squared. That's correct. -3 times -4x is positive 12x. However, this very last one, -3 times +3, needs to be a -9, not a +9. Very common error. Now, another one here, common mistake, 2x, dealing with variables. So 2x times x is 2x squared, and forgetting to distribute the 2x to that second 3 in the parentheses. Very common mistake. This should be plus 6x right here. Another common mistake that students make is that they just think that we can divide both sides of an equation by a variable. We cannot do that because when we do that, we're saying that we could divide by a 0, but we can't, right? X could be 0, and if we divide both sides by x, that means you're saying it's okay to divide both sides of an equation by 0. So instead what we do is we move this 2x to the other side, and it becomes x squared minus 2x equal to 0. We factor out an x, and when we set this equal to 0, x could be 0, or x minus 2 could be 0, giving us x equal to 0 or x equal to 2. So it's not just x is equal to 2, it's x equals 0 or 2. Now, another common misconception is with systems of equations, understanding where they come from. So what is another name for the solution to a system of equations? Where the solution is right here, where the lines meet. This is also called a point of intersection. And what that means is that these two lines share that point. So they have the same x and y value at one point. And that's really important to understand because that means the x and y values could be set equal to each other within these systems of equations. In this case, two equations, we can set the x and y values equal to one another. Now, when does a system of equations have no solution? Two systems of equations, or two equations within a system, have no solution if the equations are parallel. If the two lines are parallel, meaning that they have the same slope. And two equations have infinitely many solutions when they are the exact same line. For example, if we have x plus y is equal to 4, and then we multiply every term by a 3, these are the same exact line, and these two equations will have infinitely many solutions in common. Now, the third misconception or mistake that students make is with quadratic equations. Let's say we wanted to factor this. A lot of students will use guess and check, and there's nothing wrong with that, but there's an easier method where you don't have to guess and check a whole bunch of different types of factors. Some teachers call it the illegal move. It's not really shown in textbooks, and some call it the AC method. If we have ax squared plus bx plus c, what the AC method says is that we can create x squared plus bx plus a times c, and then factor from there. So here we'll have x squared plus 14x plus 3 times 8, which is 24, factor from here. So now we have x plus 12 times x plus 2. Well, now this isn't the actual factorization of all this up here. Instead, what we can do, we can say, let's say this is equal to 0, x will be equal to -2 and -12. And since we multiplied this 8 by a 3 earlier, we'll divide both of these by a 3. So x will equal -2/3 and a -4, and that factors into 2x plus 3 and times x plus 4. I think this should be 3x plus 2, actually. That makes more sense with the leading coefficient being 3. 3x plus 2, just like that. Now, in order to find the vertex of any quadratic function by completing the square, a lot of students forget that whenever we add this right here, whenever we add something like this +3 squared, in order to complete the square, we take half of 6, which is 3, and square it so that we can factor into this really nice binomial squared. We're actually adding a whole number here, right? We're adding a 9, but not just a 9, but times that 3. So from this step to this step, we're adding a 27. So in order to balance that out on this side of the equation, we have to subtract a 27 so that we keep the quality of this we maintain the balance of this equation. So f of x should actually equal here 3 times x plus 3 squared minus an 18. Now, for this one, whenever we're working with functions, function errors occur all the time. And when we're working with functions, treat whatever is within these parentheses as a box. So in this case, x is within a box. So whatever we plug in into f of x, all of this in the box will be replaced into every x that we see. So this isn't the correct answer here. We'll have f of x squared plus 3, and that will be all of x squared plus 3 squared plus 3 times that x squared plus 3. And that becomes a whole nother thing that's not this right here. So this becomes x to the 4th plus 6x squared plus 9 plus 3x squared plus 9. And in the end, we have x to the 4th plus 9x squared plus 18. Now, finally, exponential properties, super important to remember. If we have a negative x squared here, that means only x is the only thing that's being squared here. This right here equals a positive x squared, and this on the bottom will be a negative, and then all that x squared right here. Another thing that we need to be careful of here is this a plus b squared. We need that middle term. So it's not just a squared plus b squared, but it'll be a squared plus 2ab plus b squared like this. Now on the bottom, in this third one, x to the negative third power will just be 1 over x cubed. It's not that this negative just comes down in front of the x. These are completely different things. This is equal to this. And this last one, if we have 2 of the same thing, that means we have 2 of that thing. Radical 4 is actually equal to 2, which is not equal to radical 2 plus 2. 2 is actually radical 2 times 2. And these are some of the misconceptions that you'll see in Algebra 2. If you found this video useful or learned something new, make sure to like and subscribe. And if you'd like all the annotations from today's video, click the link below, enter your email, and you'll have it in your inbox in no time. I cover topics like these in my Algebra 2 course. You can try for $7 for 7 days. I'll see you soon in my live lessons.